All right, we have another one that's quite similar to A1, but it's slightly more tricky because you need to remember your unit circle in order to answer this correctly. That's why I think this is probably like a higher grade problem. But for those aiming for like an A or an A minus, it's still a good idea to try to solve it and know how to solve it. Again, the solution itself isn't hard. It's the unit circle that you need to revise in case you've forgotten it. I've personally learned that thing so many times and I just always forget it. No, I think there are some interesting ways in which you can remember the unit circle more easily, but that's a matter of another video, right? So let's just take a look. The principle of solving is the same. So you take a look at the expression and you think about when something could go wrong, maybe go to infinity, or when the function might be discontinuous. When might we have a zero in the denominator, for example? And then, again, the second step, if you find some sort of a discontinuity, you need to check if it's within this interval, right? If it's not, we don't care about it. Okay, so when could this function when could this function be discontinuous? It could be discontinuous if this thing equals 0, right? Because then we would still have an infinity. So when does 2 times sine x minus 1 equal 0? Well, to start off, I'll just move this to the other side with the opposite sign. So I'll have 2 times sinus x equals 1. And then I'll just divide both sides by 2. So I have sine x equals 1/2. Now here's when the knowledge about the unit circle kicks in. There are actually a lot of values of x for which sine x equals 1/2, right? Because sine is a periodic function, if that's what it was called in English. Therefore, we only need to think about if there's any value of x within that interval for which sine x equals 1/2. And that's why the unit circle is useful. So between 0 and 1/2, which are, if you draw the unit circle, typically you have, sorry, not 1/2, but pi over 2 I meant. Oh my god. Pi over 2 is usually here, 0 is here. Let's say that's the center of the circle. And if you think about it, you had that pi over 6 for which, pi over 6 should be somewhere here, right? Pi over 6 for which your sine of x is 1/2. Is it within the interval? Yes, it is. Therefore, that's a problem, right? That's a discontinuity that we found. But again, you just need to remember that sine of pi over 6 is 1/2. As well as all of the other values of the unit circle, because obviously the professor is not going to give you the exact same problem on the midterm. So the problem is, and it's again an indefinite, infinite, oh my god, infinite discontinuity, because again, the denominator will go to 0, top is 1, so we have vertical asymptote. Therefore, we have, so x could be pi over 6. And then you write pi over 6 belongs to the interval between 0 and pi over 2. Therefore, we have an infinite discontinuity at x equals pi over 6. And that's your final answer for this one.